Good afternoon, everyone, and thank you very much, Tom, for giving such a comprehensive description of the CobBauge project. My name's Steve Goodhue. I'd just like to quickly let you know what you're looking at, which is the CobBauge project. We have got 6 partners, including the University of Plymouth. In the UK, we have Hudson Architects, along with the long-standing partner EBUKI, hence the presentation from Tom. But also we've got ESITC, the Technical University in Caen, Unicon, which is the old Central University in Caen, and also PNMRCB, already mentioned, and Francois Strief, that looks after that particular element. What we're going to do today is we're going to take you through some of the practical elements of how the wall's being built, and we're going to give you a little bit more detail and show you a little bit more of the physical evidence of what we're actually producing here at the University of Plymouth. If you have a quick look over here, what we've been looking for is at some structural mixes that Tom discussed within his presentation, and also a thermal mix down here. This is clay slip with 50% hemp, and this is looking at the structural mix. This is 2.5% hemp fibre, along with a clay-rich subsoil. Tom mentioned briefly the fact that we were producing some different panels, and Becky, thank you very much indeed, Becky, for putting the renders on. These are typical of the types of panel that we're going to be looking at as far as the durability measurements overall for the project. But in the end, as Tom indicated, we're mixing some structural mix with some insulating mix to go overall to give us a complete wall. And just to give you an idea of how much better the insulating mix is, I'm just going to ask you to come with me, and we're going to have a quick look at a thermal camera, which is showing you the results of a quick demonstration. What you've got here is you've got 2 samples, one insulating, just here, and one structural, just here. And both of them are sitting on some hot plates, both at the same temperature, more or less, 172 over 70 degrees. And if we look at the screen up here, we have the results from the thermal camera, exactly the same temperature, and yet the insulating mix is actually allowing only a surface temperature of 24 degrees, whereas our structural mix is giving us a surface temperature of 35. So approximately 10 degrees difference for the heat flowing through the insulating versus the structural. And that is a nice physical bit of evidence showing you how well the wall actually will work when you can add an insulating layer to a structural layer. Well, what we're going to do now is we're going to move across and we're going to show some of the mixing process. I'll just let Kevin introduce himself.
Hi, I'm Kevin Owen. I'm a senior technician with the CobBauge team at Plymouth University. I get to do the fun stuff at this end. You just see this is the messy bit where we combine all those elements that we've been talking about, the soil, the slip, the shiv, etc. So what we've been doing here, we've mixed up some slips. That's all ready to go. It's very thin, creamy sort of substance to it. And we've got our traditional, if you like, traditional cob. And this has already been pre-mixed. So we've got fibres in there, we've got some aggregate, and we've got the clay soil already mixed there, ready to go. If I show you the material we put into the slip, this is hemp shiv. So it's the inside of the hemp plant. We found that it has some very good thermal properties when we mix it with our slip. And the whole lot, when we mix it, goes in here on a little mixer. And if I just turn it on now, you can see that merrily mixing away. Takes all the effort out of it. We get a very good, well-distributed mix. And it only takes a few minutes to get to its mixed state. And then we can empty it out, and then it's ready to put on our wall. Sometimes we like to leave it for maybe a day, for a few hours, just to consolidate it a bit more. But basically, when that's mixed, we can put it into our wall structures that we're building over here in the lab.
Thank you very much indeed, Kevin. Just now I'd like to pass you on to Jim. Jim, can you introduce yourself, please?
Hello there, everyone. I'm Dr. Jim Carfrae. I'm a research fellow on the CobBauge project. And we're standing here in the heavy structures lab at the Brunel buildings at Plymouth, where we're building 2 full-size walls in order to take the testing of the CobBauge system to the next stage. So on this side, we have a wall that is starting in its second lift. The formwork has been raised up to allow that. There is an opening in this wall, which will form a doorway. And the total height of the wall will be 2.4 meters. So using the full scale of the material, it's 600 millimeters deep. It's 2.4 meters long that way and 2.4 meters high. And it will have a companion wall, which is started on the first lift here, which is the same size, but without an opening. Caitlin here is applying some of the thermal mix to the first lift.
Caitlin, would you like to just quickly introduce yourself?
Hiya, I'm Caitlin. I am a technician that works in the lab and just going to be helping out with some of the building.
Thank you very much indeed.
So why are we building 2 such large walls? We're building a pair of them side by side because they're both going to have a wall plate on top, then joists going across, and on top of the joists we will apply the dead loads of a typical roof or second story. Then we can demonstrate to people in real time, in a real form, the strength of the material. So for people like building control, planning authorities, whatever, there will be physical manifestation of the CobBauge project. And then finally, if you see above, you will see there's a large steel frame above these walls. From that, we can apply hydraulic pressure to one of the walls to crush it to destruction, which will give us the final figures for the compressive strength of the composite wall.
Thank you very much indeed, Jim. I'll just take you across to Dr. Matthew Fox, who'll just tell us a little bit more about some of the more scientific elements.
Hello, everyone. So I'm over here in the corner where we've got a box of equipment here. This is all of the moisture sensors that we have connected up to a data logger. We're using Campbell Scientific data logging equipment, and we're using these moisture sensors. And these are moisture sensors that you traditionally use in the ground to monitor the ground conditions for plants and things like that. However, this time we're using them in a very different way, and in an innovative way. We're using them within the cob wall to try and work out the drying rate throughout the different layers of the cob construction. We have other different moisture sensors, and we're doing comparisons between the different sensors to try and work out the speed at which that cob dries out on the structural side and on the thermal side, and to see if whether there's anything we can learn from that. We're also combining this data with shrinkage data that we're getting from a 3D Leica Disto apparatus. So that's measuring in three dimensions the wall samples over a period of several weeks, and we're looking at how these wall samples start to shrink and relating that back to the moisture data. We have other monitoring ongoing as well, so we're using heat flux sensors to monitor the thermal conductivity through these walls. We'll probably be doing that on the prototype buildings, not necessarily on these walls, but certainly something for the future. And we have lots of other experiments lined up. We'll also be using thermal cameras. So we have the thermal imaging demonstration over here. So we have the structural layer and the thermal layer on 2 hot plates. These hot plates are set to 70 degrees Celsius. And on the screen here, we have the structural layer and the thermal layer. And I think we can use the thermal camera really nicely to demonstrate the thermal performance, or the potential thermal performance of the thermal layer compared with the structural layer.
Matt, I wondered if you could just let us know how far into the wall do those moisture sensors go?
Okay.
And I'll just hold the camera just close enough, I think. Pardon us viewers, but we're trying to be COVID appropriate in a very tight space.
Yeah.
So apologies for that.
It's quite difficult to see because they're buried by heaps of cob right now, but you can see the tail end of one of our sensors. For those of you who are familiar with the Soil View 10 sensor from Campbell Scientific, this is a 0.5 meter long rod that has 6 moisture sensors and temperature sensors along the length of the rod. So that's buried within the wall. We also have 3 of these sensors equally spaced throughout the wall. We're going to be trying more varieties of these different sensors to see whether different combinations or different arrangements give us better or worse results.
So essentially, we're looking at 2 walls, just to summarize, being built full height. This particular wall has got an opening in it, so it's going to be very interesting to see what actually happens with the lintels and some of the other detailing. This wall that Kevin is actually raking up the thermal layer is actually being produced at this very moment. So you're seeing some scientific related work to do with earth building and getting it through the building regulations happening before your very eyes. What has happened is the main structural layer is being produced first, and that was done this morning. And it's done, if you can see there's a stop end that Kevin has produced so that we can actually separate the 2 layers. And then Kevin is now, and Caitlin are both placing the thermal layer next to it. And by a process of addition, we're hoping to be at least 2 layers up. Do you reckon we'll get 2 layers today, Kevin?
Yes, very possibly. The quickest part is actually building the wall. It's the preparation of the material that takes the time. And certainly the thermal side is a lot easier. We both agree it's a lot easier to put in place than the structural side. But it's a fairly simple process. And Caitlin's helping us today. And this is the first time you've done this, and you built half this wall. So
well done, Caitlin. Thank you very much. How did you find it as a kind of first time of going to earth construction? Is it an easy process, simple, or quite complex? How did you find it?
It's fairly simple. You don't need a gym membership. I will say that much. It is quite hard work, but it's very tactile. It's quite rewarding when you see it being built so quickly. So yeah, it's nice.
And just for the audience, your background, Caitlin. I mean, what was your first degree?
So I have a civil engineering background. So this is a little bit different, doing things that aren't concrete and steel. But yeah, I've mostly worked in wastewater. So this is very different for me. But
great.
Yeah, good.
Thank you very much indeed. Well, what we need to do is now get back to base and take up with a Q&A session. So what I'm going to do is just block and get the camera around to the right side. Morgan, if you want to bring in Tom as well.
Getting back on a different laptop.
Are we all going on stage now?
That's the idea.
Okay.
Just waiting for those guys to come back up again, I'm hoping. Yeah, very interesting. Just that's Clayfest, actually. That is actually Clayfest. That is, you're standing there and you can put your hand into a bucket of slip, and then you can stick it into a bucket of hemp and see how the hemp sticks to the slip, and it tells you an enormous amount, doesn't it?
We can use this again another way. Yeah.
Yeah. And so, and then obviously with Clayfest, at lunchtime you'll kind of wander over and you'll talk to Dr. Jim, and he'll give you a sort of a deeper insight, and then you possibly are a builder, and then you'd say, yeah, of course we'd be doing our mix with a front end loader, and then you'd be having a discussion about that, and it's this sort of dynamic thing that Clayfest does so well, and that we hope we will get a little bit more of in the networking sessions, that you can see who's been adding to the chat and see if you can get a one-to-one with them. I can't see them coming up. So maybe I should just start with you, Tom, on some of the questions that have come through the chat line. And this one, which is not sort of directly related, but somebody put something about where they could find open source directory sort of details for natural building, and whether you've got any immediate thoughts about it.
A directory for natural material in the UK, do you mean?
Well, I mean, the thing is that this could have come from Nicaragua or New Zealand. I mean, I literally...
I don't think there is one global resource for ecological building materials, because, different materials are appropriate in different places. I think Tom Woolley, who I think speaking this afternoon, has got an excellent book that outlines some, and there are other books that go into more other bioregional materials. I think, as with CobBauge, the science and materials are always developing. And I mean, the interesting thing about CobBauge is you're taking a traditional technique and knowledge base from with some very generic materials, and by applying science, you're coming up with something that works, on a building site and economically in a completely different way.
Yeah. And this is this is why Ibuki exists, and the European network exists, that we're trying to share as much as we can. Aha! They're here.
It's welcome to the hospital.
Absolutely fantastic, guys. That was just such that was so Clayfest. It was brilliant. So yeah, we just started in on some Q&A. One of the things that I just wanted to mention that I don't think I had never heard said before we started CobBauge is that we looked at some different soil types and we looked at some different fiber types. And one of the things that came out of the fiber types was that actually, if you have stronger fibers, you get a stronger cob. Does anyone have any comment about that?
Just briefly, part of a lot of the fibers was a multiple of different variables as far as its choice is concerned. And in which case, if you are using, for instance, hemp straw, the difficulty of actually mixing with it means that even though it's actually a stronger fiber than flax, it's just unworkable. So in which case, it's not just the strength that we're looking at, it was also looking for the ability of the contractors to be able to mix with this particular version, particularly with mechanized machinery that you wouldn't see an artisan using. The machinery just can't cope with some of these, or it has to be so manly that frankly, it's out of the price range of a lot of people that can physically use it. But it is interesting, you're absolutely right, Roland, that the stronger the fiber, in most cases, the stronger the cob. However, that effect is marginal. The bigger effect appears to be about the choice of the subsoil and the clay content, as we all know.
And so you say that we all know, but there's a question that came through about your soils mix. Do you want to just talk about that a little bit?
Yeah, sure. I mean, the mix we're using today has come from one of the slides that you put up earlier, Roland, from H.G. Matthews, the brick manufacturer. They found that to be it's a waste product for them because it's the subsoil sitting over the top of their clay, but it seems to have just the right amount of clay in it that if you mix some ballast with it, it works far better than some of the more silty soils that we've been getting, even though those soils historically have been used in vernacular terms in certain areas which have got a lot high prevalence of cob buildings, which is quite surprising. But no, you are right in that the soil itself is a vital component.
And I think one of the key things about the project is that we're trying to develop a material that in a way carries that strength of traditional earth construction, of being able to use a wide range of soils from from a large range of locations, rather than it being, you know, a product that's commercially marketed and is controlled in that way, so that you can use your local soil, you know, with appropriate guidance to use CobBauge on site. But there's also the potential for flying factories, or for it to be prefabricated. We're trying to, as it were, deconstruct traditional cob and reformulate it for contemporary construction.
Yeah, I've got a shopping list here. I'm just wondering, you know, how far we're going to go down on it. One of there's been a little thread coming through about the compaction of the insulating layer. Do you want to just have a little talk about that?
Yes, the compaction is quite interesting, really, because we are fairly uniform with ours in that it's manually compacted. So we're just using basically wooden staves with a flat bottom to it, and it's not particularly compressed to a kind of mechanical degree as, say, you would with a compressed wall would be. But so long as it's uniform, there we go. That's the ideal. So there's no particular weight there. It's just the user dropping it onto the mix itself. What we have found is that if we compact the thermal side, and if it's over compacted, we think there's a tendency for it to spring back, and that's probably going to happen within the first day or so, couple of days. We've noticed that. We certainly found that when we were making our smaller samples that we were putting through our heat flow machine. And if it's over compacted, it tends to expand out. So we have to keep an eye on that. And having said that, though, it's not made the two separate pieces delineate in any way. I think that was one of the main ideas that people had, that if we were to combine these two materials, that number one, they would just split anyway because they're two different things, and secondly, they would shrink at different rates. And we're noticing that neither of those applies. And you know, the assumption is that there's a transference of moisture between the two that's actually beneficial to both sides. So effectively, they're drying at the same rate.
So then we've had a question about prefab.
Prefab?
Good question.
Go on, Tom. Talk about prefab.
So the traditional cob, you have a building season, which in our part of the world runs from kind of April to October, and after that, you know, it's too dark, wet, and generally miserable to build monolithic earth that you're trying to try out. So there's a traditional period for building, and that doesn't really suit a lot of modern construction. It's fine for a craft-based construction site, but if we're aiming to bring CobBauge into mainstream construction to deliver on the low carbon benefits, then it needs to sit within the process of mass commercial construction, and that rarely gives you the luxury of that degree of control over the program, and often there's constricted physical space on site, and the need for a rapid construction process due to cash flow. And so prefabrication has a role to play in that, in that you're forming CobBauge into elements that can be assembled like Lego blocks on site, and you take the quality control and the whole drying time off site, and you do that somewhere else. It can be near to site or beside site, or it can be in a remote factory, and it just gives you more flexibility, a different tool in your army about how you can deliver CobBauge for different sort of commercial situations.
Yeah, I mean, it begs all sorts of questions. This thing about program, that we've taken program now to be that you can do anything at any time of the year, and we know that it doesn't really make a lot of sense. And there are many parts of the world where you have a rainy season, and actually that's when, you know, you shouldn't necessarily be building. You should be doing it in the dry season. And we have there's a certain element of training with the design team and the build team and the business team to say, actually, do this kind of work in those months. Have it all ready so that in the winter you've got a nice roof on it and now you're working indoors. But we have to make the construction industry a little bit more sophisticated than it currently is.
Yes, that's a big
yeah. Well, no one said it was going to be easy, right? I mean, just once again, that has just been a fantastic session. We're just coming to the end of our morning